Dear audience, recently I read that the first thing presented in a talk is best remembered. So therefore, allow me to kick off today's webinar with our key message as of today, which is we as Covestro want to make every drop count. You may now ask, what does it actually mean? So observing the technology shift from analog to digital textile printing, we at Covestro have deeply looked into what it takes from a raw material perspective to propel this disruptive technology to the next level of capability. So we definitely want to enable you to create aqueous pigment inks with, on one hand side, soft hand feel, and on the other hand side, elevated fastness properties by offering a polyurethane and isocyanate toolbox. So with this being said, it is a great pleasure for Yin Dan and myself to welcome you to today's webinar. Let's dive right in. Looking into the textile printing market as of today, screen printing is still predominant in the industry. Around 93% of all printed textiles rely on this analog printing technology, which has certainly pinnacled to its full potential over the past years and is by now a well-established technology. So this technology definitely leads to stable processes as it also relies on mature and yet proven material solutions. However, the textile printing world as such is changing. So there are higher demands towards increased sustainability, cost-efficient mass customization, and also shorter times to market. In this context, the digitalization of textile printing is a logical next step for innovative businesses along the textile value chain, as it offers a greater flexibility to react to changing demands and also more granular control of production processes. According to current market data, inkjet printing is gaining in importance, even though one has to admit that the overall market volume of 7% as of today is, in comparison to screen printing, not too much. So 7% market volume roughly account to 3 billion square meters of digitally printed textiles. And even though it may not appear to be too much in comparison to screen printing, one can nevertheless recognize the technology shift happening, giving the rapid market growth with the indicated compound annual growth rate of another 15%. So inkjet printing as a digital printing technology is certainly a new and disruptive technology, which requires advanced formulations, but also a re-evaluation of raw materials. Throughout the past years, there are or have been different ink technologies established in inkjet printing. Amongst those are reactive acid and disperse inks, dye sublimation inks, and last but not least, pigment inks. As for reactive acid and disperse inks, they have to be carefully selected with regard to the textile substrate used. In addition to this, and as a rather further disadvantage, there are many process steps required. So next to the actual printing process, a pre-treatment needs to be applied. One needs to steam the printed textile, wash it, and finally also apply another finish. This, of course, leads to an enhanced energy, but also material usage. Dye sublimation, in contrary, is much more favored in the industry, as it is less prone to migration and does not require any washing cycles. However, there are also two major disadvantages for this technology. The first one is that the printed paper first needs to be transferred onto the textile substrate, which requires a lot of handling and equipment costs and potentially also an environmental impact. And second of all, it shows a lower light fastness, meaning that the printed textiles will start to deteriorate, so start to fade much faster under the exposure to UV light. Pigment inks, in contrary, have much more gained in importance throughout the past years. Why is that? There are a couple of reasons for this. First of all, starting off with the sustainability aspect. So in contrast to the before mentioned ink technologies, there is a lot less energy needed, as there is no steaming and also no washing required. On top of that, there's also less water, but also less chemicals that need to be used in this process. In comparison to screen printing, so the before mentioned analog printing technology, there's even an 85% waste reduction recognized and also stated in most of the reports. Another decisive advantage is that pigment inks as such are substrate independent, meaning you will be able to achieve good fastness properties and also good color strength independent of the type of textile used. So if you were to print on cotton, on silk, on polyester, on blends, etc., you will always find a good performance simply because the function of pigment inks is based upon physical bonding. At Covestro, we strongly believe in the power of this pigment ink solution, not only because it's also seen as one of the dominating ink technologies in the entire industry, given the fact that also in recent years it has exhibited one of the biggest growth, but we truly believe in being able to solve all remaining questions with regard to textile printing, or digital textile printing moreover, by relying on pigment inks, and therefore also put it in the focus of our raw material developments. In any case, before diving into the raw material solutions that we would like to present today, let me kindly introduce you to the topics that we have prepared for today. So having just outlined the shift from analog to digital printing and the corresponding disruption of the printed textiles market, I next would like to introduce Covestro in a nutshell, especially to those of you who do not know us yet. In the following, Yin Dan and myself will highlight how we at Covestro want to contribute to solve remaining challenges with regard to pigment inks. With this, we will introduce our novel InScan toolbox with which we want to make every drop count. We will then follow up with a performance proof of our polyurethane and isocyanate raw material solutions, and furthermore also like to use the opportunity of today's webinar to one could say maybe zoom out a little bit and take a snapshot of how we at Covestro do not only want to push boundaries in digital textile printing, but in digital printing in the entire coatings, adhesives, and inks world, and therefore also build cross-industry success stories. After around 30 minutes, I assume we will then conclude today's webinar and kindly invite you to participate in our Q&A session. So therefore, as Lucy before mentioned, please feel free to post your questions also throughout the time of the webinar in the Q&A section. So at Covestro, we are very eager to push boundaries. So we create materials the world relies on every day, and our high-tech polymers are used in nearly every area of modern life and in multiple different industries, whether it would be about automotive, healthcare, construction, cosmetics, electronics, sports and leisure, and many more. We strongly finished off the past fiscal year with another 15.9 billion euros in sales, as for which we built on the innovative mindset and also competencies of 17,900 full-time equivalent employees. After last year's acquisition of DSM's resin and functional material business, which, by the way, substantially expanded our portfolio of sustainable coating resins, we now operate at another 50 production sites globally. Those range from smaller sites, which are mainly designed for regional purposes, all the way to world-scale plants, which ensure a reliable and efficient supply to our customers with a global presence. However, at Covestro, we do not only want to produce materials, we also want to tackle fundamental challenges, which is the shift towards a circular economy. So here we are taking big steps together with our partners and customers to close both energy and also material cycles. At Covestro, we look back at another 80 years of ideas and inventions, given the go-ahead by Otto Bayer, who first discovered polyurethanes, but also Hermann Schnell, who first synthesized polycarbonates. So we are just as eager to push boundaries also in the future and of what's possible with polymers, especially with our 1,500 employees working in R&D. With regard to our digital textile printing activities, we aim to support our customers throughout the entire value chain. So the textile printing value chain, as known, certainly has changed in the run of digitalization, especially given the fact that e-commerce platforms are now able to also produce single-digit lot sizes in a very cost-efficient manner. It gives individual designers, but also smaller volume brands, the opportunity to enter the textile printing market at rapid speed. Being at the top front of the textile value chain, our expertise at Covestro certainly lies in the synthesis of polyurethane dispersions, but also isocyanates. In order to evaluate whether the raw material solutions that we aim to develop also meet the demands from our customers, so whether it be ink producers, OEMs, e-commerce platforms, brands, or also end consumers, we aim to follow up on the entire development process internally. So therefore, we formulate inks according to a standard recipe, and then test the binder and crosslinker solutions with regard to their jettability and open times. So therefore, we have several inkjet printing equipment in-house in our AD lab, covering, for example, a pneumatics materials printer, but also an Epson direct-to-garment printer. So relevant application testing, whether it be wash fastness, crock fastness, abrasion resistance, or other application testing, is then also done in our lab and according to industrial standards. In order to continuously also improve the quality of our binder and crosslinker solutions, we closely monitor the quality and analyze relevant material properties.
Today, we are proud to introduce our inkscape material toolbox developed for digital textile printing. Covestro offers solutions to tackle challenges in every step of the entire process chain. Before printing, you may apply Imprepum DL53 10/1 as a primer for pre-treatment of the substrate to achieve better printing quality. And in printing step, a series of PUD benders with various properties can be used to fulfill the requirements of different substrates, different processes, of course, different final applications. And on top of ink layer, you may additionally apply a finish coat with our Impregno DL2611 or Impregno DLCF to achieve some special effect. For example, excellent resistance to chemicals, to abrasion, very dry handle, or the glossy appearance. And in each step, crosslinker Improfix 2794 can be incorporated to further enhance the performance, such as crock fastness or wash resistance. Improfix 2794 is an aqueous dispersion of blocked polyisocyanate. It has good compatibility with most PU resins and is free of pot life limitation. Covestro has more than 50 years of expertise in PUD development for application in textile industry. And we are also one of front runners in PUD bender development for digital textile printing. PUD as a very complex heterogeneous system. Their properties are decided mainly by three key factors: chemical nature of building blocks, how those blocks connect to each other to form functional polymers, and physical transformations during production process. You know, polyurethane has millions of varieties regarding to the chemical backbone and also chemical structures. So only with proper chemical design and very precise process control, the desired property of PUD can be achieved. Via collaboration with the whole value chain, we have learned what properties of PUD bender is needed to create high-performance pigment ink and also the final products. For example, small particle size, low viscosity, and good filtrability is very important to achieve good jettability. While the mechanical property of the PUD bender is greatly influences the hand feeling of the printed products. And adhesion of PUD bender to the substrate is almost directly correlated to the color fastness. And stability and resolubility of the pigment ink is greatly dependent on the mechanical, dependent on the chemical nature of the PUD bender, and so is wash fastness. In next slides, there's a chart summarizes the characteristics of our injectable benders with unique properties. In the chart, the x-axis and y-axis indicates the final performance of print products brought by the pigment inks containing different PUD benders. From bottom to top, our different PUD benders can provide handle from soft to very soft. And from left to right, our different PUD benders can provide fastness from good to excellent. Here, fastness refers to a rubbing fastness tested according to standard method ISO 105x12. And the size and color density of each bubble represent the particle size and viscosity of each PUD in supply form. As we just mentioned, those two properties are quite important to the jettability. For example, Impregnal DL1620, which has very small particle size and the lowest viscosity in our portfolio, has been proved with excellent jettability. If additional to jettability, excellent fastness is needed, Impregnal DL1602 will be your best choice. It also has very good resolubility and long open time. If haptic property is of more interest, we will recommend Impregnal DL1618. It's the softest resin in our portfolio, and it has excellent adhesion on different textile substrates. It's also especially suitable to be used in the white ink layer. Another good choice for good adhesion is Impregnal DL1623. It also has excellent adhesion on different textile substrates, in addition to its very good jettability. Last but not least, Impregnal DL&SD with very dry, very soft and dry handle, although not dedicated to digital textile printing, but is very suitable to be used in compounds because of good compatibility and economic advantage.
So at this point, I would like to pick up on the portfolio which Dunn just presented and kindly introduce you to the performance of Impregnal DL1602. So this product has actually been specifically designed for inkjet printing and is based upon a polycarbonate backbone. With a typical mean particle size, which is lower than 85 nanometers, and a typical viscosity measured at 23 degrees Celsius, which is lower than 200 millipascal seconds, Impregnal DL1602 as a binder for pigment inks shows excellent jettability and extended open times. However, this does not only go back to the particle size and the viscosity, but it also goes back to an excellent shear stability. So we measured this shear stability by using a capillary rheometer with a homemade ring slit device. For this measurement method, the flow-induced aggregation and aggregate retention is measured across the ring slit. So if there's a stable sample, the pressure will adjust itself to a comparably low constant value given the particular viscosity of the sample. As you can see in this chart, Impregnal DL1602 shows a low pressure throughout the entire measurement period. And by the way, this was measured at a shear rate of 375,000 reciprocal seconds, which is roughly 3 times as high as shear rates which are normally occurring in an ink nozzle, which are around 100,000 reciprocal seconds. In contrast to this one, I pulled up a reference with poor stability. So this is actually a typical behavior of a material, in this case a dispersion, which is more of an unsuitable for digital textile printing. Next to these properties, I would also like to highlight the modulus at 100%. So as Yin-Dan indicated earlier on, the mechanical properties as such are a good indicator for the resulting haptics. So a 3.8 megapascal modulus actually is a good indicator for a pleasant hand feel, meaning a very dry and soft handle. We then moved on to evaluate the printability of Impregnal DL1602 in a standard recipe. So for this one, we relied on an ink formulation, including a pigment dispersion from Fujifilm, from their RxD APD1000 series, in our case, a cyan-based pigment dispersion. We used our Impanil DL1602 at 17 weight% in delivery form, our Imprafix 2794 as our low temperature deblocking polyisocyanate at 4 weight%. So both of these products actually had been presented by Yin early on. We also included water in order to adjust the final viscosity. We used two kinds of humectants, as is propylene glycol and bicotol PC, in order to avoid any kind of film formation inside or outside the nozzle. Buc Dunwet as a wetting agent, and last but not least, Aquacer 513 as a wax in order to furthermore improve the ink performance on the printed textile. So with our Dematic materials printer, and in specific with the drop watcher, as you can see on the right-hand side, maybe it's small, but nevertheless, here's the drop watcher. And this one we used in order to, first of all, evaluate the jettability. And what you can see down here is actually a video of the resulting droplets, which are jetted. As you can see, there is no nozzle clogging. We do not have any ligaments, meaning that once a droplet will hit the textile substrate, it will have nicely formed a droplet and will not have any tails or similar. And we were able to maintain a droplet speed of 6 meters per second throughout a wide range of different frequencies. So we used this in order to then print on two different kinds of textile substrates, which we then evaluated with regard to the application performance. The first textile substrate that we printed on is actually a typical jeans fabric, consisting out of 93% polyester and 7% elastane. And here we evaluated the wash fastness, the crock fastness, and the abrasion resistance in accordance with industrial standards. As you can already see, according to the grayscale rating which we performed, the overall performance of this printed textile is excellent. So even, let me kindly highlight the maybe more critical parts of the test, of the application test. At 60 degrees Celsius and after 5 washing cycles, we remained a grayscale rating of 4. After 50 turns for the wet crock fastness, we remained at a grayscale rating of 3. And after 50,000 turns for the abrasion resistance, we remained a grayscale rating of 4. Despite the excellent fastness properties, you can also tell from the image that the resulting color is very brilliant. Also, it shows a good edge sharpness, and these results are actually even more satisfying to us because we did not apply any kind of pre-treatment for this printed textile. The second textile substrate that we printed on is a 100% cotton knitted textile. As for this one, we did actually use a pre-treatment, especially given the many staple fibers which tend to, of course, stick out from the textile surface. And here we used our non-ionic aliphatic polycarbonate polyether polyurethane dispersion, which is also commercially available under the brand name Impraperm DL5310/1, and which is also part of our InSkin toolbox. So as you can tell from the above mentioned grayscale ratings, the performance is nearly comparable to those of the polyester-based textile substrate, even though one definitely has to say that we had some losses in the performance on the crock fastness and also abrasion resistance, which partly, however, also do go back to the fact that the cotton knitted textile is intrinsically less durable than the polyester-based textile substrate. As you can see down below, from the image quality, also up here, we were able to generate really vibrant colors and an even more astonishing edge sharpness, which certainly also goes back to the fact that we did apply a pre-treatment as such. So in the run of our toolbox development, we did, however, not only rely on internal investigations, we also emphasized to build strong cooperations with innovation partners around the globe. So whether it be Inkbank in China, Verajet in Turkey, Verajet in Canada, and then Bersa in Turkey. And with the kind support of Bersa, we can now also highlight an external performance proof. So Versa at this point printed with a Bercotec Print B Pro with 720 drops per inch. And here the ink relies on selected binder systems from our Inkscape toolbox, as well as our crosslinker solution. As you can already tell from this video, there were vibrant colors generated for this ink. And those vibrant colors actually remained also after 10 washing cycles at 40 degrees Celsius. So you can, it is very hard, at least for me, to tell the difference, apologies, to tell the difference between the original printed test pattern and the washed sample. Given also the crock fastness under dry and wet conditions, Versa stated to us an excellent color intensity paired with elevated wash and also crock fastness properties. So this made us very confident that our binder and crosslinker solutions are very much suitable for digital textile printing, as they certainly also show good handle properties, meaning they're very soft. And therewith, we are actually also able to resolve the trade-off between fastness properties and handle properties, and actually also color intensity. So with this, let me kindly summarize today's key messages. Being an enabler for you to accelerate the shift towards digital textile printing is definitely on the top of our list. So the technology shift from analog to digital textile printing is happening now, and we are very much eager to support you in such. Despite remaining technical challenges with regard to pigment inks, we strongly believe in this pigment ink technology and put it in the focus of our raw material developments. With extensive internal investigations and on the basis of plenty of customer feedback, which we highly appreciate, we were able to generate a polyurethane and isocyanate toolbox. As I just showed, with regard to the internal and also external performance proof, we were able to show the good suitability of InSkin for digital textile printing. So at this point, all is left for me to say is that we are a global team. So we are pretty much located in every continent, almost every continent, I would say, and we are utmost eager to serve you with our material solutions for all steps along the digital textile printing process. And one thing I would also like to highlight, and which is actually even better, not only the textile printing world, but the entire coatings and adhesives world is changing, which gives us at Covestro the chance to learn from one another and also to build cross-industry success stories. So with this, thank you very much for joining our webinar today. Yindan and myself are now very much looking forward to your questions. And by the way, in case you would like to reach out to us also subsequent to today's webinar, please feel free to scan the indicated QR codes for further contact information. So thank you very much.
That was brilliant. Thank you so much. So we'll head right into the Q&A then. First question is the InSquin toolbox suitable for direct to garment, direct to film, heat transfer, and roll to roll likewise?
Okay. Maybe I'll just dive right in, and then you can comment if you would like to add something. So definitely we do see that regarding to the different processes, there are also different requirements set, as for which there is most often not only one binder system which meets all the different process requirements, I would say. So we do know of one product, Impreneal DL1620, which has proven to perform well in all three processes. However, we would always indicate to look closely into the, how to increase the performance of the final process by really diving into the USPs of our binder systems. So here, of course, we would be happy to also recommend selected products to you with regard to the process that you aspire to focus on.
Brilliant, thank you. Next question. What are the curing conditions for the printed textiles?
For the curing conditions that we recommend, and this always, of course, now relates to our Imprafix 2794, which is, as Dan, I think earlier also mentioned, the blocked isocyanate. So here the blocking agent, or we can activate the blocking agents or deblock it moreover, apologies, at 135 degrees Celsius. So if you make sure that you can exceed this temperature for roughly 2 to 3 minutes, then you'll be good to go for the curing. We do have customers who also aim to go up to higher temperatures. However, my feeling about this is that there are a lot of isocyanates or more of a cross-linkers which are suitable for pigment inks. However, those tend to require higher curing temperatures. So really 135 degrees Celsius for 2 to 3 minutes would be sufficient at this point.
That's great, thank you very much. Next question. What are your experiences regarding the compatibility with different pigment dispersions?
I'll maybe again just dive right in. So for pigment dispersions, we have seen that they strongly also impact the final performance of the ink. So also we had to make some different, or start some different initiatives, one could say, on using different pigment dispersions. We are right now well off with a Fujifilm solution. However, we also do have customers who rely on Cabot solutions, and we also have many customers who also use their own pigment dispersions. But however, we do see that there is a strong interaction between binders, crosslinkers, and pigment dispersions. Not maybe also to name all the other ingredients, maybe I would say, of the ink formulation. But as before mentioned, one has to be quite cautious. However, we did find good compatibility of our systems with many different pigment dispersions so far.
That's brilliant. Thank you very much. Next question. What is the resin type of the binders?
So Yindan, I'll hand over to you for your idea if you like, or...
No, sorry, my net connection is not so good, so I missed the last question. So I didn't hear anything in last 30 minutes.
Oh,
okay.
Sorry.
Can you hear me now?
Yes, now it's better.
Oh, fabulous. I'll repeat the question then. What is the resin type of the binders?
Oh, that's simple. If you're talking about the hydrophilizing type of those binders, they are all ionic types. And if you're talking about the backbone of those binders, there are different types: polycarbonate, polyester, and polyether. So there's great flexibility to be selected based on your needs.
That's brilliant. Thank you very much. Next question is, can your inks provide good adhesion to polyester? Usually pigment inks show poor adhesion on polyester.
Yeah, thank you for this question. I think we were able, don't know when this question had been placed, but I think we were able to show on one of the last slides where we had printed on the polyester elastane textile substrate that we do have good adhesion properties. At least this is what you can tell from the resulting fastness properties. Yeah, so our experiences also with polyester are very good.
That's great. Thank you very much. Next question is, what are the curing conditions after printing for the blockade isokinete?
Yeah, so I think this is what we just touched upon. So just briefly repeating 135 degrees Celsius, 2 to 3 minutes as the final curing step would be sufficient.
Ah, fabulous. Thank you. What kind of pre-treatment is needed to be done before printing?
Yeah, so I could maybe say that obviously, or intentionally, of course, it would be nice to not use any pre-treatment after all. However, we do also see that, especially for textile substrates such as the cotton knitted textile, which I showed earlier, it is definitely in favor of using a pre-treatment. For this one, we highly recommend to use our Imperperm DL5310/1, so our non-ionic PUD. We have until now always recommended to apply it via foulard, even though I'm also aware of the fact that some customers of ours are aiming at using this in the inkjet process as well. So just given the particle size and also viscosity of this product, it may also be suitable to print it digitally. However, I must admit that we internally do not have any further experiences with this one. So really using Imperperm DL5310/1, then applying it via foulard. If you have any questions on the intended formulation or similar, please also feel free to get back to us subsequent to the webinar.
That's great, thank you. Could you tell me how many colors are available?
Yeah, maybe just to clarify at this point, we are a raw material supplier, meaning that we will not produce inks ourselves. We basically look at the binder system and the crosslinker, both for the ink, or maybe for the ink, for the pre-treatment, and also for post-treatment, respectively finishing. But we will not be producing inks ourselves. So there was also maybe answering the question. In theory, I would advise you to customers of ours who definitely have inks based on our binder solutions in all 4 colors. So yes.
Fabulous, thank you. Next question, what does InSquin stand for?
That's a good question. So InSquin is actually our umbrella brand that we use in our textile coatings activities. So this is actually also where we're coming from. Textile coatings, where you of course need to have, next to the fastness properties, etc., and the corresponding structure that you build up, you also need good handle properties. And also you would need to have sustainable solutions. So in total, InSquin stands for our sustainable coating solutions for the textile industry.
That's great, thank you. Can I just do a quick reminder to the attendees, if you're wanting to submit any questions, I would recommend putting them in the Q&A chat box, the Q&A box rather than the chat box, as then we'll be able to answer them within the order that they are submitted. Thank you. Sorry, next question. Do you have any binder that come from natural sources?
Yeah, don't know, Yidan, if you want to comment on this one first from a R&D perspective.
Yeah, currently all of our binders are petrol-based, but we are also, of course, thinking of developing new binders with more sustainable raw materials, like you said, nature sources. That's definitely in our plan, in our and fit our strategy. Yeah, let's looking forward to the next generation.
That's great, thank you very much. Next question. Can we get the good fastness and appearance when print with natural based fabric?
That's a good question. I mean, intentionally, I would say yes, but honestly speaking, I'm not aware of the grammage that we had for our fabrics. So maybe we can follow up on this one. In any case, as before shown, we also had some cotton knitted textiles that we used. Don't know if you refer to any other fabrics based on natural fibers, but maybe we can follow up subsequently if you like.
Thank you very much. Next question. What would the surface tension of the inks formulated be?
Yeah, so of course, every ink formulation itself will show different surface tension, I would say. The ink formula we had been using for our trials roughly showed a surface tension of, if I remember correctly, around 30 millinewton per meter. Sometimes also lower. I've also seen some commercially available ink formulations, as for which I think it was roughly about 26, 27 millinewton per meter. This is at least from the top of my head, the data. But if you would like to elaborate further, again, please feel free to reach out.
That's great. Thank you very much. Is the crosslinker blocked? Could we get a DSC data of the crosslinker?
Yindan, do you want me, or
Yes.
you want to answer yourself then?
Yes, in prefix 2794 is a blocked polyisocyanate dispersion. And I think it's not a problem to get a DSC test result of this product, and you may also test yourself if you want.
That's great. Thank you very much. Next question. Given digital pigment printing represents only 4 to 5% of the digital textile print volume today, how quickly do you think the market could grow, and is there any possibility of it replacing reactive ink printing?
Yeah, again, I think a very good question. Maybe start with where we stand today. I think there's, I think 7% as of now accounts to digital printing inks as such. Amongst those, it's only 6% for pigment inks, which is certainly not too much. However, we do see that it's developing very, very rapidly. If we were to know how rapid and which kind of market would be behind this, this would of course be also nice for us to know. In any case, we are quite confident that with the 15% compound annual growth rate, this market will furthermore grow rapidly. We also see that with not only the raw material solutions, but also the technical developments that are currently happening with regard to print heads, on being able to also print high viscous fluids, etc. So there's a whole bigger world, I would maybe say, that's opened up for digital textile printing inks. But honestly speaking, I would not dare to say how quickly it also could replace any kind of reactive inks or similar. Yeah.
That's great, thank you. We'll just do a couple more now, and then that'll conclude the Q&A session. If you have submitted any questions, don't worry, we'll be sending these to Inga and Yingdan, so they'll be able to contact you directly, providing the information has been allowed to. So just a couple more. How do you recommend the measure hand feel of the ink?
Yeah. Oh. So I could maybe say, of course, we do it quite in a more practical way of simply, of course, testing ourselves. But we do use the mechanical properties of our binder solutions in order to correlate those to the resulting handle properties. Of course, this also goes hand in hand with how much crosslinker did you use, what is the rest of the ink formulation. However, we have experienced so far that also given the I think 30 or 40% solid content, which in the end remains in the ink on the textile substrate from the binder, this is a very good indicator for the entire handle properties of the printed textiles. Yeah, don't know if you can comment on this one, Yindan, but at least this is my my understanding.
Yeah, I fully agree with you.
Brilliant, thank you very much. Next question. After the printing process, what is the drying or fixation step required?
Yeah, so again, I think this goes very much into the direction of the before mentioned curing conditions. So here I before mentioned the 135 degrees Celsius for 2 to 3 minutes, at least for our Imperfix 2794 as a crosslinker, and previously 100 degrees Celsius, most probably I think also for 2 to 3 minutes to evaporate any remaining water beforehand in order to then move on to the actual cross-linking of the printed textile.
Fabulous, thank you. And this will be our last question for today. I need a high tensile strength binder system like Inprinel DL 1602 or even higher strength, but we need it to be adhesive as well. What would you suggest?
Linda, I don't know if I can forward this question to you. Otherwise, I would dare to answer.
I only have. I think maybe you could try to combine DL 1602 with other benders which has excellent adhesion to see if we can achieve a balanced point to fulfill the requirements in both directions. But of course that needs investigation and practice and tests to verify those ideas. I think we can consult our AD colleagues and get back to you later. And we are happy to cooperate with you to solve the problem.
That's excellent. Thank you so much. And thank you everyone for joining. It's been a wonderful presentation by Covestro. Again, a recording will be sent to everyone via email of the presentation, and also we will send a Q&A report to the presenters so they're able to get back in touch with you for any questions that we've not been able to answer. Thanks again, everyone.
Thank you very much. Bye.
Bye.
Bye-bye.